LL1 parser. LL1 parser is an example of top-down parser. Here, first L stands for left to right. That means that it would start to create our parse tree from left, then only it would go to right. Second L stands for left to right derivation, and here 1 stands for one look ahead token. One look ahead token means that it would only parse one token at a time. This is a diagram of LL1 parser where parsing program uses stack, parsing table and input buffer to create the output. Stack and parsing table are used to store our intermediate outputs of the program, and the input buffer is the memory which stores the string output that we need to generate. Okay, so here this parsing program takes the input from all of the input buffer, stack and parsing table, and it would create the output that is a parse tree. Steps to create a parse tree. In order to create a parse tree using LL1 parser, we need to follow 3 steps. The first step is to find first and follow. Second step is used to create parse table using this first and follow, and the third step is to create parse tree using stack and parse table. Let's take an example and find the steps one by one and create a parse table for this particular grammar. So here we have to find the first of R, first of A and first of D. Okay, this is called as parse table. Here on the column side we write the name of the terminals. So what are the terminals that we have in this particular grammar? So terminals are small a, small e, b, c and D. Okay, so these are the terminals that we have in our grammar. So what we would do is we would write these terminals in the columns. So here we would write A, E, B, C, D. Okay, so here we would write it like this, and here we write the name of the variables. What are the variables that we have? The variables that we have is R, A and D. Okay, so here the first step is to find first and follow. Okay, so let's find the first of R. So first of R is A, first of A is B, first of B is D. Okay, so since first of R is A, we would write the production of R in this column. Okay, similarly, since the first of A is B, we would write the production in B column. Okay, similarly, first of B is D, so it would be written somewhere here. Okay, I'm pointing it out and writing it. Okay, so it would be written somewhere here. So this is how we create a parse table and we put the values of productions based on the first and follow values. Now let me fill the parse table, and now we would move on to the next step. Here what we would do is we would quickly just put the values of terminals here. Okay, E and C. Okay, and here we would be writing the name of the variables. So here will be the production A, B, A gives B, C, and B gives D. Okay, so here we have successfully completed the parse table. Now our next step is used to create a parse tree using this particular parse table. Okay, so here we would use a stack. This is a stack. Okay, so stack has a dollar inside it. Okay, so what it would do, first step is we have to insert a start symbol. Our start symbol is R. Okay, we have successfully pushed the value of R inside the stack. Okay, now the next step is to open the production in reverse order and pop the variable. Okay, so when we do this particular step, what we have to do is we have to create first parse tree. Okay, so we would pop this out and we would write this value in a reverse order. Okay, so reverse order would be E, B, capital A and small a. Okay, so we have successfully popped out R and we have put the contents of R inside the stack. Here this is a string that we need to parse. Okay, so at first the pointer will be pointing at the beginning of the string. So you can see that the top of the string is pointing at A and the first content of the string is also A. So there is a match. So when there is a match, what we would do, we would strike out this particular variable and we would pop this out. Okay, popping this out would eliminate this particular variable, and now the pointer will be pointing at A. Okay, so pointer is now pointing at A and our string is now pointing to B because A is already parsed. Okay, so here since A is pointing at the top, so what it would check, what A will see on reading B. Let me repeat my words again. What A will see on seeing B. So here we would use the parse table. What A would see on seeing B. So here what we would it would do, it would use this production. So it would use this production and it would expand it here. Okay, so we are expanding A and we are putting its content in a reverse order and we are popping out the variable A. Okay, so this is the step that we have done till now. Okay, we have popped out the contents of A and now the top of the parser is pointing to the B. Okay, and our string is also pointing to B. So our string is also pointing to B and our stack top is also B. So what it would do, there is a match. Since there is a match, we would pop out B and we would increment this value. Now it is pointing to C. Okay, so the stack is pointing to C here. So C and it is also pointing to C, so there is a match. So again it would pop out a value of C and it would increment the string now to D. Okay, so it is now at the top of the string we have B. Okay, so the step that it would do here is what B will see on seeing D. What B will do on seeing D. So what it would do, it would use this production. So we would expand B to D and we would put the contents of B inside this stack, okay, and pop this value. Now our pointer is pointing to the top of the stack, which is D, okay. So here you can see that our string is also pointing to D and our stack top is also D. So there is a match. So since there is a match, it would pop out the value of D. And popping out the value of D means we have to increase this counter to E. Okay. So now our top of the stack is also E and our string is also pointing to E. So it would pop out. Okay, popping out means there is no content in this stack left and stack is now empty. Okay, because all other items are popped out and we have only dollar left. Since we have only dollar left, that means that we have successfully parsed all the string, and this is the parse table that it has generated. So this is a parse tree which is generated using this particular parse table. Checking LL1 parser. So we understood that how we create a parse table and a parse tree using LL1 grammar. Now how to check if a grammar is LL1 or to check if a grammar can be parsed using a LL1 parser. So there are basically three rules that we need to keep in mind. The first rule here is if a production looks like something like this, then we have to find first of alpha 1, first of alpha 2, and we have to find the intersection. If the intersection is 5, that means there is nothing in common, then it is a LL1. Similarly, we have to check second option. If the first of phi 2 and first of alpha 2 and first of alpha 3 intersection is phi, then it is LL1. Similarly, first of alpha 1 and first of alpha 2's intersection is also phi, then we can collectively call that it can be LL1 parsed. Let's move on to the second rule. Second rule says that if the grammar looks like something like this, then we have to find first of alpha 1, first of alpha 2, and we have to find out the intersection. On finding the intersection, if it is phi, then it can be LL1. Similarly, we have to find these all conditions and we have to find the intersections. If the intersection is phi, then only it can be LL1 parser. The third rule is that the grammar should not have left factoring, it should not have left recursion, and it should not be ambiguous. If any of the grammar falls in this category, then we can clearly say that the grammar is not going to be parsed by LL1 parser. Let's take this example and understand how we can check that this particular grammar is going to be parsed by LL1 grammar or not. So what is the first step? The first step is we have to find the first of S. Okay, so first of S is A. Okay, first of A is C comma epsilon. First of D is okay. So here we have to find follow of A. What is the follow of A? Follow of A is first of B. First of B is D, and we would strike out because it has epsilon here. Okay, now what is the follow of B? The follow of B is small b. So follow of A is dB. Okay, similarly follow of B is B. Okay, so here you can see that there is no intersection between first of A and follow of A, and there is no intersection between first of D and follow of D. So since there is no intersection, then we can clearly say that it is not, then we can say that it is L11 parse. Okay, because there is no intersection, then we can say that it can be parsed by L11 parser. Now let's take another example. Okay, so we have to find first of S. First of S is A, B and epsilon, and follow of S is, here you can see that follow of S is B dollar A. Okay, so here you can clearly see that we have an intersection. Okay, B is common in both of them, right? Since B is common, so the intersection of follow of first of S and follow of S is not equal to phi. That means that it cannot be parsed by L11 grammar. L11 parser. Now let's take the third example. Here we need to find the first of S. First of S is A and epsilon. Similarly, the first of A is C and epsilon. Follow of S is first of A. First of A and first of A is C, and we would put the value of epsilon here because we have epsilon here, and we would put the contents of of dollar. Now we would find the follow of A. The follow of A is dollar. Now you can see that the intersection between the first of S and the follow of S is phi, right? And the intersection of the first of A and follow of A is phi. So since there is no intersection, we can say that it is parsed by L11 parser. One important note that we need to keep in mind here is that we only need to find the follow of variable if it has epsilon in the production. If there is no epsilon, then we need not to find the follow. I hope all the examples were clear to you, and if you have any doubts, you can comment down below. Thank you.